Yeah, so these are some, I have some slides I put together. This past 2 weeks have been both LPC and XDC, where I've done some talk about ions. These are slides based on what I presented there and also some discussions that have come out. So I'll just go through those. Okay, so if you want to go ahead and take a picture of this, like I mentioned, the past week has been Linux Plumbers Conference and X Developers Conference. There's notes from the Etherpad and also an XDC video where I took the recording of me giving this talk and also answering questions. So those will be available for the slides as well. But okay. That's a short ion history for those who don't remember where ion came from. It was a memory allocation framework originally written by Google to handle various types of then carved out memories. These days, its primarily use is providing an effective enumeration of types of memory that are available for user space to allocate, and with DMA BoF. Mostly for use in Android, although there have always been some level of interest in non-Android use cases, but primarily Android-based. So this is one I actually got a question at LPC about why we're still talking about ion, because someone thought that we had actually replaced it. And the answer is still that, yes, we do end up needing ion, just because it's still it's effectively a simple wrapper around as a buffer, as a simple wrapper as a way to get DMA buffs for user space. There has still been nothing else in the kernel to replace similar functionality. It's mostly that if you need something that isn't actually tied to another framework, such as the During framework or UFL2, then ion can fill a niche that perhaps will allow you to allocate those buffers, maybe use them processing in user space, and eventually pass them on. So this past year, what exactly did happen? I'd say a lot ended up happening. I ended up taking an approach about ripping out a lot of code that in ion that become unnecessary, and start working towards a new allocation ABI, and really simplifying things a lot. So the end result is that the current ion ABI is just an allocation ioctl and a query ioctl. Anything else that needs to happen is mostly just handled through manipulation of the DMA buff FD. I'll be talking about some of the stuff related to ABIs and query ioctls in a bit. There are patches that have been pending for AOSP. As of post-XDC, patches for libion and backwards compatibility have merged, but patches for Gralloc still need another revision. But those are pending and have been tested, so the hope is in the near future those will all be merged, so that upstream AOSP will have support for both the old and new versions of the ABI. And big thanks to John Stoltz and Sumit for helping push those forward. Okay, so the question that again comes up is, why is ion still in staging? What's blocking it from moving out? And from my perspective, it's really the ABI. One of the big things with ABI is trying to figure out what to do with dev ion. There's been a lot of interest in trying to split out dev ion into having multiple, what I think of as sub-device nodes, more corresponding to heap. So instead of just dev ion, you have dev heap 0, dev heap 1, et cetera, et cetera. There have been patches actually pending this week to add support for this, which I've been reviewing, and they've been going back and forth. Factors that have been going into looking at this have also been backwards compatibility, just because we don't want to break things yet again. So the thought going forward is that we'll keep the existing dev ion node as an old backwards compatible interface, and then allow the existing dev heap whatever as a new interface. And these will be able to exist in parallel for the kernel, but the old interface will be able to be disabled under a kconfig. So if your new platform only supports the new interface and you want to secure it down that way, that's the way it can go. One issue that has actually come up somewhat related to this while thinking about it today is how exactly to be able to then actually secure the heaps. One of the goals with moving to new ABI was to have heap IDs be discoverable. One of my old gripes with the older ABI was that heap IDs tended to be hard-coded such that you would into a UAPI file, and changing those back and forth was very difficult. So the solution I came up with was to have a query octal to be able to find out what heaps are available and what the heap IDs are. But the problem then becomes, if you use that then to enumerate heaps, dev heap 0, heap 1, heap 2, how exactly do you lock that down with SE Linux then? Just because if the heaps themselves are going to be dynamically created at runtime, that doesn't quite work with a static security mechanism like SE Linux, which relies on knowing what the dev nodes are going to be. It was one possibility was pointed out that, okay, you can just give them all the heaps the same security policy, but that kind of defeats the point, possibly, of splitting them out into separate subheaps. So that is one of the issues to work through in terms of trying to figure out what the future of this might be. Mostly to make sure that if we do go with the route to actually split this out to yet another ABI, it will actually provide some way to meaningfully lock down the heaps, possibly through something like SE Linux, without actually requiring hard coding of the heap names or IDs. So if anyone has ideas or opinions, I'm happy to hear them now or talk afterwards.
Are you publishing attributes of the heap as well?
Yes. The question was, are we publishing attributes of the heaps? Yeah. When you query the available heaps, you get back a list of heaps, their name, their heap IDs for allocation, and also the type.
I thought these would. My assumption was these would just appear in SysFS somewhere, and we could even use UDEV rules to give them unique names for locking down and things like that. That's a possibility. I brought up these SysFS attributes as on the list, but I think people originally thought that the proposal was to try and allocate SysFS. How familiar are you with this approach about trying to give through SysFS and then use UDEV too?
So there is no UDEV in Android.
Yeah, but
so that's one bit of it. The other bit is, even if we did, we could definitely look at this when we. So Laura will talk about the debug bit in I think a couple of slides, and we can talk about it with that.
I mean, but that would be something we'd have to investigate, I guess. And yeah, that's.
So, a general question for you. I haven't looked at the API in a while, but it occurs to me that the different attributes of memory could require different APIs for things, for memory operations on those heaps. Is that in the API at all?
The question is, could different memory attributes require different operations in the API at all? The answer is no, not at the moment. Nobody has really come out with a proposal that requires any actual different operations than what exists already, just using the standard mmap and standard existing DMA BoF APIs to be able to get scattered data list and act on it that way. Some other issues have come up, which we'll talk about in a bit. One issue is secure buffers and how you deal with those attributes. And we have been brainstorming some ideas about how to be able to pass around details essentially a way to be able to pass around allocation-specific information to a generic DMA BoF to be able to get that. So we're thinking about ways to do that, but as far as actual operations on memory, we haven't given any thought to that. I don't know if there's something more specific you're thinking of, or...
Do you have an example?
Cache flushing operations or something. I don't think you need to do that on a buffer. I mean, these kinds of problems have always been kind of inherent in ION and never really solved, and that's why all these heap attributes have always been kind of hard-coded on things. And so sounds like there still might be some open issue.
It's a possibility. For cache flushing, that's always, we've also taken a new approach to that as well, where we're relying on the standard DMA BoF APIs for synchronization there. I don't pretend that iron is 100% complete, and if there are additional requirements, I think those are something that we'll have to work through to meet them in either possibly the DMA BoF generic layer. So,
but you don't think we'd have to evolve the API? Or if we do, we'll deal with it then?
I can't think of a way to evolve the existing API right now. I would probably say adding ioctals with careful review is always an option if there's something that's neither allocation or query, if there would be other operations. But as far as things like, say, cache flushing, that's already handled through the standard DMA BoF APIs. So, something there.
We tend to allocate very large DMA buffs and want to do cache flush on a sub-range of it. But, so we're trying to solve that a different way.
Sub-ranges have came up in a discussion at LPC, so we'll be looking at proposals for that. If you have a proposal for that, you're welcome to submit it upstream. That makes it a lot easier to review and try and propose something. But yes, we've heard that feedback before. Okay. Yeah, so onto the allocation API. So this is as it exists today, passed through the ioctal. There was some discussion about what exactly we should do to try and expand it automatically, just because there was already some comments that 32 bits of flags is not enough space. Generally, the way it currently works is that 16 bits are reserved for ion, 16 bits are reserved for heap-specific usage, and the 16 bits are not actually enough. And I think the conclusion is that we may very well just add a flags to field and just go ahead and use the unused space, just to get mostly hearing feedback from the graphics people who are well-versed in APIs that go ahead and just expand out, give people a chance to do things. Okay. And then, since a lot of people may not have seen this before, this is the query ioctal. It's designed to be called from user space, and what you get back is a list of heaps that are with information like heap type, heap name, and heap ID. A common question then is what exactly you use to match on in user space to be able to get the heap ID. And the current proposed solution is to be able to match on the heap name. The assumption is that there'll be some way with how you set up your system to know exactly what that name is called. That is platform specific, which as has been discussed before. But I think the logic is right now is that you still can't do this with perfect zero information right now, and matching on the heap name is the best idea we have right now to be able to figure out the heap ID. So, okay, did I cover that? Okay, a popular one that comes up is about heaps, and can we add exactly new heaps? And I think based on, again, discussions, I think new heaps are certainly welcome, but there needs to be a reasonable use case, such as a open source user, similar to how the kernel graphics driver will not take a kernel graphics driver unless there is an open source use case. I'm going to be a little bit flexible about what an open source use case is. This doesn't necessarily mean there needs to be complete integration with something, but I don't just want to see heaps dumped into ion that are only ever used with some proprietary module that's shipped in user space. Again, there's some flexibility here. I'm not saying don't submit it, but try and have a use case in mind. And then there's still also the question about what? Yes?
So you mentioned updating Growlic earlier. I assume that's the Molly Growlic and High Key.
Yes.
Because there's not really a Growlic, generic Growlic in
Yeah.
AOSP that uses
Yeah.
ion. So would you consider that an open source user space?
I consider AOSP open source enough for this purpose.
But that Growlic is just a downstream copy of whatever that's trickled through a vendor from ARM. Has no real upstream. It's just.
I would think that, but on
So
the other
libion is actually the user. for the ION API.
But if ARM decided that they wanted to add a heap and then added it in their gralloc and then that filtered out and you did an update of high key,
How would you know about it in the kernel?
well, they would, if they didn't submit it upstream for the kernel, then
Yeah.
they would be using their own heap.
And the yeah. So I mean, like Laura said, I think there is that bit is still open to interpretation. And
So I guess we'll just get into the usual DRM debate about new interfaces where does the user space side go in first or the kernel side go in first?
I expect it could go very, very well turn into that. On the other hand, if I haven't heard, apart from the secure buffers, I haven't heard a whole lot of other people wanting to dump stuff in there. But on the other hand, I think I don't want to see 6 different implementations of secure buffers. I do think we run the risk of running into this, which is why I'm saying I'm willing to be a little bit flexible, but I think it does need to be reviewed in some place. And I don't, once I moves out of staging, I just don't want to see everything submitted all at once and then say, there, we're done, without some level of review. Okay. And related to that, in terms of old heaps, I didn't end up doing bindings for either carve out or chunk heap because I want to delete those. I'm considering posting a patch just to delete those and saying anyone who wants to bring those back can figure out a good way to have those enumerated with the new setup. A lot of this is because the current method of ION basically doesn't touch anything related to device tree. I think there would need to be some mechanism to, like a compatible property to add to a device tree to be able to link to carve out and or chunk heaps. So I didn't really want to go trying figuring that out, so I figured I'll leave this to anyone else who is super enthusiastic about keeping chunk heap and or carve out heaps alone.
And I assume you haven't heard of anyone wanting to do that yet?
I hear about it every now and then. Every time I say we want to delete chunk heap or carve out heap, no, we're using it. I was hearing that ARM were using it for some things internally and they were interested, but then I also actually see that maybe they're less interested. So I'm kind of willing to let it try and delete it and see exactly who's willing to speak up and actually do the work to come up with something reasonable. Okay. Another issue that's come up is debug accounting. With all of the stuff I ripped out, the existing debug infrastructure didn't end up making a lot of sense. Clients were basically redundant. Handles and buffers were also redundant given we have DMA buffs. So there isn't a lot of ION-specific debugFS infrastructure. And there's still a question about, though, what to use then when leaks occur, just because memory leaks are going to occur. So part of what I've been thinking about is taking advantage of stuff at the generic DMA buff level, which is essentially it's just an anonymous inode, and then using LSOF to be able to list out all the FDs available, and then linking them back in some way to be able to see exactly which processes have references to DMA buffs. This needs some updates to DMA buff, also because everything uses the same name right now. We also got the suggestion from Greg Hackman at XGC about looking at unique inodes and then continuing through scanning through proc as well. It's an option, but ideally what I'd eventually like to have is some sort of user space program that will be able to scan procfs and scan proc / LSOF to be able to get this information and tie it all together to give a nice summary about what DMA buffs are actually available. And I was talking to Sumit as well about possibly moving some of this information towards SysFS as well and giving DMA buff a real SysFS interface as well. Again, just to sort of tie everything together. Did you want to say anything?
Read only.
Yeah, read only SysFS interface for information there. Part of this is motivated by there's a move towards getting rid of debugfs on Android devices, so moving anything that might actually be useful for runtime debugging to SysFS would be useful. So again, this is sort of nebulous work, but it is, again, we realize this is something that's required to actually debug and ship a device, so we're thinking about it. Open problem, patch is accepted. Finally, testing. One of the things is that we do want to try and look towards maybe getting more ion self-tests going. There's been a big push in the kernel towards things like K-self-test and other CI testing. One thing that needs to, I need to finish working on is tests that working toward use the DRM VGEM interface, which is designed as a test interface for sharing stuff back and forth. I started work on that, then got distracted by other things. Someone also recently is working on submitting a sample setting of FDs back and forth through socket interface. They've been submitting that upstream at the kernel as well. So ideally, be able to send stuff back and forth to be able to do basic validation of ion APIs to have something to either run a K-self test or anything else like that. Okay. libion. So yeah. So libion was a, as the name implies, it's a library for calling ion interfaces, but having to call the ioctals directly. It exists as an AOSP repo. This has now been updated for the new APIs with backwards compatibility. I think the conclusion is that this is going to stay as is. Just we can try and I think the goal should be trying to get more people to use this directly and not call the ioctals, just because this makes it easier to possibly do cleanup and fix up any problems that might come up later. Destaging. So I've been making references to moving ion up staging. I think the answer for when this happened is that should happen soon, but not too soon. I want it to go out, but not before it's at least been reviewed and generally accepted as ready. And I think the suggested location from XDC was to have it live under dev DMA BoF, since it essentially is an allocation framework for DMA BoF in filling in that niche. So,
do you think the API needs to be stable and used in an Android release first, or the couple?
Stable, absolutely. Used in an Android release, I'd have to.
That you're talking 6 years.
Maybe to put it another way, do you think vendors will use it before they actually move their vendor trees to something recent or something soon in the future when we're close to a stable API?
My hope would to be able to do something like use something like the High keyboard as an example of a prototype for to be able to work out some of the details. Now, I understand this certainly doesn't cover all use cases, but I mean, I'm open to feedback, I guess. Are there concerns that it wouldn't actually find problems if it's not actually using Android, or? Okay.
What was Brian's question originally?
Brian?
For me, I think, I mean, you've got a good plan on the kernel side. I want to see this get plumbed into Android, and like you were suggesting, I want to see all clients move on to libion. And I think to me that would be a good way to lock down the API for it.
So the ASP ones, I think I can't talk of all ASP clients, but at least we've tried to prove that on High key. Libion right now has support for both the new interface and the old one. That got merged last week. And the High key dialog patches are actually sitting in my bucket because I'm here, so I've not been able to work on them.
Problem is bigger, it's bigger. It's bigger than just older API, newer API. We're guilty of vendor-specific extension of this stuff. So we need to go figure out how to get all this pumped back into Android and not hack everything up.
So one thing that Laura and I have tried to do is to talk to different members, different vendors out of the room and see how we can help. And so we've spoken to a few people from different members, and hopefully we'll have some things that we can add up here. So for example, the topic about doing flushing for sub-ranges, that's definitely on the radar. We have to think about where it should sit. Ideally in the DMA BoF sync API perhaps, but if you have other better solutions, we're open to the implementation review and everything. Similarly about different heaps that could be used. So secure heap, I think we'll talk about it, but secure heap keeps coming up in discussions with everyone, but nobody wants to really talk a little bit more to help us try and decide something that is generic enough for everyone to use. So those are the places I think we would request members to come up and, if you want to do a one-on-one or however, but tell us more so that we can design or give us a design.
Yeah, no, I think we had these discussions, or not we, but Qualcomm and others have discussed.
Sure.
Yeah. My main concern is I want to move all clients to libion in one shot and not move it part way, and all right, next year maybe figure out what we're missing again, redo all this stuff. So I'm just kind of curious how much of an Android plan is in place.
One good thing at the moment is 414 is going to be the next LTS, but no one is going to ship a device with 414 anytime soon. So we have a little bit more time to actually figure out, and whatever needs to be changed will get backported to 414 LTS is my thought process. You feel differently about it?
I was just going to say, one of my focuses has been trying to make Ion more palatable to the upstream community, and at least make sure those requirements are met. And I think, hopefully, again, as Sumit said, is that if we can get things generally agreed upon as workable for 414 with at least some basic review, then that will mean when people move to it, hopefully things have been reviewed enough that, again, there'll be some level of Android integration, but it won't be too great. One area I guess I do have concern about would be the fact that we haven't fully tested this with, say, a camera or video data path. So I need to try and think about a way to be able to test those with the new Ion frameworks and be able to figure those out, just because while they may not necessarily use, some may use Ion directly and others may not, they're still a heavy user of buffers that could possibly be affected by this. Yeah.
Laura,
Yes.
what's the advice to us? We have done another session these days. So I wonder, what is the advice you have to us regarding the secure heap allocator we have started working with? It's currently based on the Android-based framework, and it's there. I guess we still need to polish a little bit, but we would like to move on with it also. So should we wait? So what's the advice here?
Yeah, okay, that's a good question, but I think the other two questions we had were related to secure buffers and hypervisors, and I think I'd like to leave those for the end. So if there's nothing else related to Android before we move on, or Ion before we move on. Major. Okay, so secure buffers, do you want to?
Archit is probably the best person to talk. No, but I mean, so I think the advice would be don't just rely on whatever is in Android at the moment. Try and use the new API and help us, if there's something that you feel is really missing, help us make it strong and stable enough.
Yeah, like for example on Android on Qualcomm SoCs, we have certain flags that kind of give a hint about what are the secure masters that are going to use this buffer, and internally we translate it into VMIDs. So I'm guessing there would be similar stuff at your end too. So I think we need to see 5 or 6 different vendors. Maybe 5 or 6 is a big number, but like a few vendors and like how they implement secure, and maybe we can have a like a heap type which says okay, slave side access control, or another heap type which is master side access control, and let people go ahead from there.
Yeah, so I think a big thing is just trying to figure out the requirements about exactly what you've done out of tree that we can try and add to Ion. I guess a good example is being able to get the secure buffer status for drivers to be able to query, is this buffer secure, to be able to make decisions. That's come up a couple of times, and I think the current proposal is to put another field in DMA buffer flags to be able to store information like this. So that's an example of the type of stuff we're looking for, whether it happens within. Ideally, it would happen in the community, but I understand that for reasons it may not. So review within Linaro about exactly what requirements are missing for secure buffers to be able to manage things like, as Archie mentioned, all the requirements for the various secure types.
One question. Primarily about using Ion in non-Android world, the traditional Linux world. So right now, if you're saying like we'll still take a couple of releases to move it out of staging, it still lives under driver staging Android. Is there an kind of an intermediate plan to decouple it with Android per se? I understand it's just semantics in the kernel kconfig, but just in terms of location.
Probably not, just because moving code is a pain, and I want to move it once and one time only. Even if it is currently not necessarily an Android-specific framework, it still primarily uses Android, and so until it actually moves out somewhere else, I'm not really interested in trying to move it again. I do understand that it's kind of weird to use it for non-Android use cases when it lives under driver staging Android, but moving it twice I think would just be not productive.
So I'm trying to understand, I'm sure this is a dumb question, but when you're talking about adding heaps, you're talking about adding heap manager types.
Yes.
Not heap instances.
Correct.
I can have as many instances of a given heap.
Yes, you can have as many CMA heaps as you can support on a system. I'm talking about adding heap types, so I don't know, optimized cat picture heap or something.
So the documentation. Yeah, I cannot find the good documentation and example code, let's say the neutral example code for the new IO code.
And this is yes, you are absolutely right. It is completely missing. This is something I think I was hoping to do when it moves out of staging, but I think I've gotten enough requests that I think it needs to happen before that. So hopefully once I'm done with all this travel, I will get some time to sit down and write some documentation, and I will probably stick it in the existing staging maybe the documentation directory?
Yeah, maybe we can make our documentation staging directory.
Yeah, I'll put it somewhere, whether it's in this staging directory or the proper documentation tree for what's going on, and then hopefully that'll make people's lives easier.
So the query API, so you had the query API, but you didn't really show us the data structure of the result. But it appeared that you're relying on the result to be an array of fixed size elements.
Yes.
That can never change, can never expand in the future. Any concern about that?
The way it works is that, this is something that needs to be documented, is that you first make the query with a null buffer. We'll turn back the number of fixed size elements you need to actually allocate, and then you can allocate the buffer that way. And so it's not that you can only, I don't think I'm explaining this clearly, but it's similar to, what was the graphics? What was the graphics query? The GBM? Okay. Well, it's similar to an octoboolean graphics that I'm blanking on, where you do the first query to get the number of elements that are going to be in the array, and so you can allocate the proper number of elements from user space, and then pass that down into the kernel.
Yeah, but I'm talking about the size of each element.
So I think what the heap query API gives you is the information about the heaps of a specific type, not necessarily the buffers that are there in that heap. So is your...
Well, I'm just wondering if we add
Oh, you mean on the fly
extra
new
flags
heaps?
or something like that, are we going to run out of, do we need to supply more information about each heap? I mean, if this stuff were all in sysfs, I wouldn't worry about it, right?
Yeah. I'd have to double check, but I believe the heap information field had a couple of fields to grow into. I think either for padding and or just for this particular use case. I'll double check on that,
But I mean, is your use case something like you have on the fly growing heaps? Heaps of, so let's say when you boot up, you have 2 system, 2 CMA, and then you later on expect them to grow into something? Is that what you're... I'm just trying to think of a use case where that will change.
No, I'm talking about API evolution.
Okay.
I mean,
Yeah.
API evolution was something that was discussed a little bit in terms of whether we should be adding in versioning to that, and I think the conclusion was that versioning wasn't appropriate. And if it's at the point where we are needing to add in that much more information, we may very well need to just have a separate query, octal query, yeah. Which, and new APIs are never fun, but trying to squeeze it in. But I will double check on the heap one to see if we can try and make the existing one work if at all possible for getting more information. So,
I think you have some results.
yeah.
What mailing list is the best list to discuss ION?
Okay, best mailing list. Currently just the staging mailing list and or the Linaro SIG mailing list. I'm subscribed to both of those. I also check LKNL for stray patches that don't quite make it through. But preferably the staging mailing list just because that covers a wide variety of things. CC and Sumit. And I think also the Android team from Google is also listed. I'm sure they're happy to be involved as well. So. Okay. So were there any further questions about secure heaps? Okay. Then I think, do you want to talk about the hypervisors or do you want me to go ahead and keep talking? Okay. Okay, one interesting use case that came up was a discussion about ION and hypervisors and what exactly that involves. I guess there's some discussion of requirements about what exactly that means because it sounds like buffers may need to be allocated differently if it's in a hypervisor versus not in a hypervisor. So there's a question about what, if anything, should ION do related to that? This is new requirements that I just heard about today, so I don't know a whole lot, which is why I'm hoping to get feedback from a BoF session. If anyone has heard of information about ION and hypervisors and would like to share stories about how ION can be improved for this use case. Archit, did you want to talk about this at all, since you brought it up, or?
Yeah, mistake. I mean, the only requirement I've seen now is that the heap type that the applications, I mean, the system heap might not be visible on a hypervised platform, and but the same code should also run on a standard, like a non-hypervised platform, I mean, a regular platform, where the system heap would be available. So the user space needs to be a bit clever to, first try out system heap and then fall back to carve out or whatever it is implemented with. Yeah. But this too is like more of a early stages of implementation work. eventually, even on hypervised platforms, you would want to use the system heap.
So you're envisioning a heap manager that when you ask it to allocate, it makes a hypervisor call that actually gets the memory from the hypervisor and maybe programs the underpinning tables to give that to the guests so that you're keeping the memory away from the guest until it's actually being allocated?
This is a more simpler approach. What I've seen is that there's just one carve-out region that's just kept completely separate from in all the guest OSs, and but we want to use. We want to use the same Android user space with on the hypervised platforms, and those applications originally used the system heap, but now you have to fall back to the carved out it. I'm not sure if I understood your understanding.
Yeah, I'm not getting the differentiation.
Okay.
So, one thing I was thinking about with relate to this is that Ion has kind of moved towards specifying what's available versus just enumerating what all is available, what all memory is available in the system. For example, right now, if you turn on the kconfig, it just spits out the system and system config heap and enumerates all CMA regions as available for allocation. I guess with the model that's being proposed is then, how does this topology change when it's in a hypervisor? And how do you expose that? And I think Sumit and I were also talking about, has the enterprise actually solved this at all? I mean, just because they're the ones who've done much more with virtualization. I imagine the answer is that yes, because they do something more like API. But this also kind of gets tricky in that there's been a lot of pushback in trying to put anything related to Ion in device tree. So if we don't actually have device tree stuff for Ion, then where is Ion potentially getting this information? Or I guess, where's the hypervisor even getting this topology information to be able to say that it comes from? So this is sort of open questions to try and think about.
Does anybody use CMA on an ACPI system?
I mean,
I guess you can do it all through the command line.
I mean, CMA is enabled on ACPI, other ACPI systems just for backing for regular driver storage, but it's just not allocated through Ion. So,
doesn't SBSA require IO use?
Anything but the first one.
okay, yeah. So I think that was really all we had. So now it's just open floor for any additional questions or comments.
I don't think we were holding back.
Okay. Anyways, well, thanks then. Thank you.